Hello friends, in today's question, in an experiment, brass and steel wires of length 1 meter each with area of cross section 1 millimeter square are used. The wires are connected in series. One end of the combined wire is connected to rigid support and the other end is subjected to elongation. The stress required to produce a net elongation of 0.2 millimeter is, and various values which are given like of Young's modulus for steel and brass are given respectively. So this question is directly based on the Young's modulus of elasticity, and herein we have two wires and they are connected in series with one another. Suppose this is one of the wire and this is another wire connected in series, and when force is being applied in the downward direction, there is a net elongation, that is a total elongation is given. Suppose it is stressed by this amount and this is our net elongation, and this net elongation is given as 0.2 millimeter. So this is our 0.2 millimeter. So it basically means that this elongation will be the combined elongation of our brass and steel wires. Suppose this is brass and this is our steel. So net elongation will be the combination of elongation of respectively brass as well as steel. So we are going to use excuse me, Young's modulus for brass as well as steel individually, and then we can combine it. So let us start from there only. So we say elongation of the wire if it is represented as delta L, then this delta L will be given as sigma L divided by Y, where this sigma is the stress applied, sigma is the stress applied, L is the length of the wire, and Y is Young's modulus of the wire. Young's modulus of wire. And in the question it is given that the wires are combined in series, therefore we can say combined wire is in series, combined wires in series. So we can write that when wires of brass and steel are connected, in series, the net elongation net elongation is sum of the elongation of both wires. Net elongation is the sum of individual elongation of wire. Individual elongation of respective wires. Therefore, we can write the formula that total elongation delta L will be equal to delta L for the brass plus delta L for the steel, and this is our delta L net. So we can modify the given formula, means this formula, in terms of for brass as well as steel. So we can write this as equal to, we have sigma L upon Y, and this is for brass, plus sigma L upon Y, and this will be our steel. Length is given as 1 for both the wires, and respectively Y is also given to us, and delta L net is also given. So if we substitute the value, delta L net is 2 into 10 to the power minus 4 sigma. Length is given as 1 meter, and Y is our 60 10 to the power 9, plus this will be sigma multiplied by 1, and it will be 120 10 to the power 9. So we can take sigma upon 60 into 10 to the power 9 as common. So we get this as 1 upon 1 upon 2, and this gives us sigma upon 120, sigma upon 60 into 10 to the power 9 multiplied by, this comes as 3 by 2. So if we, now it's a simple adjustment of the equation. So from here we can write that sigma will be equal to 2 into 10 to the power minus 4 multiplied by 60 into 10 to the power 9 multiplied by 2, and this whole divided by 3, and this goes away by 20, and this will be our coming as 8, and will be equal to, so we can say sigma will be equal to 8 into 10 to the power 6 Newton per meter square. So we check the options that are given to us. The option number C is the correct one, but it is written here incorrectly, so it has to be 8. Okay. So option number C is the correct option, and we can say this is the net, or this we can say this is the stress required. This is the stress required, and option C is the correct option. Option C is correct. So this question was based directly on the formula itself. This completes the question. Thank you.